Today we're going to talk about the discriminant. The discriminant comes from the quadratic formula. It is the blue part of the quadratic formula, the part under the square root. And you might notice that the front part of the quadratic formula actually gives you the negative b over 2a, which we use to find the vertex in standard form. So from the quadratic formula, we have your vertex in standard, x value, your vertex in standard form in red, and then the discriminant in blue. What the discriminant tells you is how many roots the quadratic has, and if they're real or imaginary. So let's look at some examples. So you're going to want to write this down in your notebook or in your book you're going to turn in to me. And we have our first one, b squared minus 4ac. If it's greater than 0, then you're going to have 2 real roots. If b squared minus 4ac is equal to 0, you're going to have 1 real root. And finally, if b squared minus 4ac is less than 0, you'll have no real roots. Oops, sorry. Which means that it would be imaginary. Alright, so let's look at some examples. We have 4y squared plus 3y minus 1 equals 0. Our a is 4, our b is 3, and our c is negative 1. Using that and finding the discriminant, b squared minus 4ac, we get 3 squared minus 4 times negative 1. That's going to give us 9 plus 16, which is 25. Since 25 is greater than 0, we will have 2 real roots to this problem. So let's look at another example. In this example, a is equal to 4, b is equal to negative 1, and c is equal to 5. The discriminant would be negative 1 squared minus 4 times a, which is 4, times c, which is 5. This gives us the value of 1 minus 80, because 4 times 5 is 20, times 4 is 80, which gives us minus 79, which is less than 0, and so therefore there will be no real roots here. They will be imaginary. Now let's think of why that is. Remember, this comes from under the square root. And if under the square root is negative 79, that tells you you're going to have an imaginary answer. And imaginary answers always come in a pair. Imaginary solutions always come in a pair. Be careful when doing that you just don't automatically take the number in front of the x as your b. You have to be sure it becomes in standard form, so you have to bring everything over the one side of the equation. This will give you 4x squared minus the 8x plus 4 is equal to 0. Then you can do your a is equal to 4, your b is equal to negative 8, and your c is also equal to 4. Using the discriminant, we're going to have negative 8 squared minus 4 times 4, which is a, times 4, which is c. This gives us 64 minus 64, which gives us 0. Since its discriminant is equal to 0, there is only one real root. That's our 3 examples, and It's not very complicated. You just have to, if you can remember the quadratic formula, then you have the formula for the vertex in standard form as well as the discriminant. The discriminant just makes it easy to determine if you have any real roots at all, because sometimes if the formula, if the function has to have a real root and you use a discriminant to find out if it has any, then you can easily say, no, there's no solution to this problem because there are no real roots. All right, see you tomorrow.